In this video, we're going to walk through the Microsoft Lab to connect your on-premise network to Azure using a VPN gateway. A VPN gateway is a great way to be able to connect with Azure if you don't have something more permanent like an express route, or if you're in a smaller location that doesn't necessarily require the capabilities and flexibility that express route provides. So let's go ahead and get started. In this case, we're talking about a scenario where you are a healthcare provider and you're moving up to Azure. You have not just a data center and a larger regional facility, but you also have remote facilities that you need to connect to Azure in a secure method, and therefore you want to use a VPN. So through this process, we will create what's called a VPN gateway and connect our environment into it. All right, more specific details about a site-to-site VPN gateway. There are a couple of different VPN types that we can set up with Azure. The first is called a site-to-site VPN gateway. There's also a client-to-site, which allows multiple clients to communicate into Azure, as well as a network-to-network VPN that we can choose as well. This scenario right here is essentially what we're going to be setting up in this lab. On the right-hand side, we have our on-premise environment, our physical data center that we want to connect up to Azure. And then on the left-hand side, we have Azure, and we want to use an IPsec tunnel over the internet to allow that to work. Now, there's two different types of VPNs that we can specify. One is a policy-based VPN, and the second is a route-based VPN. If you are setting up VPNs for your environment, you most likely know those differences. If you don't, go ahead and research them. There are a couple of different VPN sizes, and these would be important to know before you deploy them in your environment. The basic maximum throughput of about 100 megabits. VPN GW1, maximum throughput of 650 megabits, GW2 for a gig, and then GW3 for 1.25 gig. For deploying the VPN gateway, there are a couple of different Azure resources that we need to set up. The first one is what's called a virtual network, basically the network that our computers will be in. Inside of that virtual network, we will need to create what's called a gateway subnet, or a subnet that the gateway can sit on. They suggest a minimum of a /27 address mask here. You can make it larger, but they suggest do not make it smaller. It does say you cannot use this for any other services. Therefore, making it larger is just kind of wasting IP addresses at that point. You will need at least one public IP address for your VPN or for your gateway. When you create your systems, you will also need a couple of different gateway types. One is called a local network gateway that essentially defines what your on-premise VPN device will look like, how to configure it, how to communicate with it, and where it is. You will also need a virtual network gateway, or essentially the VPN device in Azure, and a connection object to connect both the local and the virtual. There is a nice little diagram right here that talks a little bit about how they work together. Overall, you see in the darker blue there, we have the full virtual network. This could be, for instance, everything describing the West Coast environment. Inside of that, we have our gateway subnet, which is going to be our /27 network. We then have the virtual network gateway and the local network gateway devices with a public IP, and then overall the connection going out through the internet to the VPN device on premise. There are some high availability scenarios, and even though it doesn't necessarily state it, these devices are highly available. For instance, in normal deployments, you will have an active standby configuration. Even though you don't see the standby device, it is there. And if the active device goes down for some reason, your VPN connection will fail over to the standby. They say within about 90 seconds. You can get into a more complicated in configuration using an active configuration. This requires some BGP configurations on your part, and therefore it will well outside of the scope of this environment. And then you can also combine this with ExpressRoute so that if ExpressRoute fails, then the VPN will kick in, or I believe vice versa, to our VPN will be preferred and then fail over to ExpressRoute if needed. Well, let's jump into it and check it out. So in this lab environment, we're going to be creating this right here. Now this looks a little bit more complicated than it needs to be, simply because, well, we don't necessarily have a physical environment to work in. We just simply have Azure to work in this lab. So what we're going to do is we're essentially going to draw a line down the middle of this page here, and we're going to assume everything over here is on the left-hand side is in the cloud, as we see here in Azure. Everything on the right-hand side is our physical data center in our headquarters environment. Because we need VPN to be set up to be able to communicate from headquarters to the Azure, we're essentially going to be doing everything here twice. So everything we would be setting up simply in the cloud or in Azure with regards to our setting up our VNet, our gateway subnet, our virtual network gateway, and our local network gateway, we're going to be doing twice. Once to simulate on-premise and once to simulate online. If you have an environment, a physical environment that you actually can set up a physical VPN environment, then you may actually be able to do this in a more traditional and more realistic environment. However, here working in the Azure labs, we don't necessarily have access to that. All right, waiting for the sandbox to create. And when it's done, we're going to start off by creating our resources. We'll start with creating the Azure resources. So everything that was on the left-hand side of the screen there, we're going to be creating our VNet. If we read this, create VNet in Azure. Going to name it Azure VNet 1 with a 10.0.0/16 network. And then a subnet to go along with that we'll call services. When that's done, we'll also create another subnet called our gateway subnet, which will be our /20/27 network. All right, looks like my sandbox is active. Let's go and copy and paste. So we're going to start off by creating our virtual network and our very first subnet, in this case, something called services. When that's done, we'll go ahead and create our gateway subnet here. If we're not entirely sure about what's going on here, we can actually open up the Azure portal and log in, and we should see these virtual networks appear. Sometimes it takes a few minutes for them to show up under all resources, but we'll see. Yeah, that's the wrong one. It will take a few minutes for it to show up. Okay, so we created our virtual networks, we created our subnets. Created our subnet. Next thing we want to do is we want to create our local network gateway network, or essentially defining where our remote target is going to be. So we can see, yep, create a local gateway in our network. It's into this resource group. The gateway IP address is going to be this. We're going to call it LNG HQ gateway. We'll notice that here the name is HQ, meaning the destination or the target for our VPN. And then we want a local prefix of this. So we'll go ahead and paste that. And it tells us down here in the description, the IP address in this case is going to be updated later because right now it doesn't exist. So with that being said, well, pretty much we have created everything on the left-hand side of the screen at this point. Not all of it. We haven't created the private IP, but we've created the virtual networks, we've created the subnets, and we've created the LNG network. All right, at this point, we can now create the same thing for the HQ side. So previously we created the Azure network. Now we're going to create the HQ network as well as a gateway subnet inside of it. So copy and paste. And copy and paste. And then because this is Azure and we're simulating both sides of this environment, we also need to create the LNG here. In this case, Azure as the target. Copy, paste. While that's running, let's see if the portal is updated yet. There we go. Now we can see my VNets, Azure VNet, HQ VNet. If we look inside of these, we should then start seeing our subnets. In this case, the services subnet as well as the gateway subnet. So we did that through the portal. We can also see this through the command line, which is oftentimes a whole lot easier to be able to see the list of VNets. Much easier, much quicker than finding it through the browser. So that was just showing the VNets. We can then also show the local gateways, which we can see in this case have the wrong IP addresses, but they have both succeeded. And that's probably the most important part at this point. And there we go. So there's our network diagram of what's been created so far. Next step, now we get to create the Azure side of the VPN Gateway. So we're going to go ahead and create the public IP address. We're going to go ahead and name this pip VNG Azure VNet 1. So pip for public IP, VNG for the virtual network group, and then Azure VNet 1. Go ahead and create that. Paste. Yep. And once that's done, now we get to actually create the VNet gateway. So create VNet gateway in Azure. We'll call this specifically the VNG Azure VNet 1. We will tell it go ahead and use that IP address we just created. Even though we don't know the IP address, the actual IP itself, it's probably in the IP range or in the output here somewhere. We're saying, yeah, go ahead and use that IP address, assign it to the Azure VNet 1, and we want specifically a route-based VPN. We can even size this, in this case, VPN Gateway 1, in order to give us, I believe that was the 100 megabits of throughput. The -- no wait means don't wait around for it to finish, just go ahead and return back. So at that point, I believe, let's see, we just created the public IP, we just created the gateway. I believe we've created everything on the left-hand side. Now we get to create everything again on the right-hand side. These commands are exactly the same, except in this case, we are talking about the HQ network instead of the Azure network. So go ahead and copy and paste for our public IP, and then copy and paste for the VNet gateways. Go ahead and paste in this next command, this watch command. What it does is it runs the Azure command right here. So it lists the VNet gateways on our network in Azure. Every 5 seconds, it will refresh this. And what we're doing is we're watching this for the provisioning state. So right here, provisioning state of succeeded. If I look through here, provisioning state, looks like they are currently in updating. I want to keep watching that until it begins and says completed, succeeded. All right, and thanks to the power of video editing, that actually went pretty quickly for you, but it took quite a while on my side. We can see right, if you look at the time up here as through the fast forward that you just saw, you will notice that quite a bit of time passed, but eventually we did reach a succeeded state for both of these. I'm going to go ahead and hit Control-C to stop my watch command there. And then I'm going to run this next command in Azure CLI. This is going to just list my VPN gateways, look specifically for provision state of succeeded, and we should see both of them showing up. Yay, that means they're both good. All right, and now we can continue on. So let's see, run the command to retrieve the IPv4 address. Okay. So what this is going to do, if I just copy that one section right there, is it's going to run a command, show public IP on the network, and then output it as a TSV, and we will see maybe. Yep, still running. It should return back with the IP address shortly. Should. When that's done, I'll go ahead and run it again. In this case, it would then actually save that into a variable called pip vng azure vnet1, which is going to be then used as the next command when we update the gateway, specifically the LNG Azure VNet1, with the correct IP address that we are querying right now. There we go. So now if I actually do an echo $ pip vng azure vnet1, then we can actually see the IP address that got returned. Then we'll run this command and update our local gateway with the correct IP that previously we'd set one, but we knew it was going to be wrong. So now we're updating it with the correct IP. When that's done, we're going to do the same thing for the HQ VNet. Remember, we're doing this twice. So we're going to run the same command this time for the HQ VNet and then update the HQ network as well. There's all of our devices, including our gateways and our IP addresses. There we go, so that completed. So we'll do the second pip and then the second gateway update. All right, so at this point, our network diagram is pretty much complete. We have gone ahead and we've created everything on the Azure side. We've created our HQ network, we've created our LNG network, we've created our VNG, we've created our IP address, and we've updated everything with the correct IPs in the subnets and VNets. We've done that for the Azure side, we've done that for the HQ side. The very last thing we need to do is actually connect them together by creating a connection object. All right, that's still running. In order to create the connection object, well, we need a shared key. So what we're going to do is we're going to create a variable here called shared key. Now we can type in whatever we want for this shared key. And if this was an actual secure environment, I would probably come out to Google and I would type in random password generator. And I would just find a random password that was, let's shoot for 100 characters long. Generate, and I will go ahead and copy that and I will save that into a notepad. The shared key, the purpose of the shared key is I want the same encryption string or the same key on both sides so they can negotiate properly and encrypt the data string together. I don't think this one's going to work because it's got a quote in it. Let's see, is that an option? Exclude, yes. There we go. A 100 character password. Ideally, this shared key is only going to be used twice. Once to set up the Azure portal and once to set up the HQ portal. So let's go ahead and copy, paste. I'm going to delete the shared key portion right there, and then copy and paste that right there. I think I need to actually quote this, so I'm putting quotes around it and enter just to be sure. Let's echo shared key. There we go. That's what I wanted. All right, and then lastly, we need to create the VPN connection. We're starting with the Azure VNet, and we're going to the local gateway of the LNG HQ, and we're updating it with the shared key we just created. And then when that's done, we turn around and we do the same thing on the other side, so we have the VPN set up on both directions. In this case, the HQ network. So copy, paste. That will take a few minutes. And when it's done, the tunnels should become active. All right, and through the power of video editing that zoomed along just fine for you, let's go ahead and confirm the tunnel is working. So I'm gonna go ahead and run an Azure CLI command, show the VPN connections in Azure, specifically this network right here, and we're gonna look specifically for the connection status. Go ahead and run that, and it should return back connection status, not connected. If we wait a couple of minutes, it should eventually refresh into being connected or connecting. And then we can do the same thing from the other side. Unknown will eventually move up to not connected to connecting to connected. And when all that's done, we will have then configured our VPN in our two different locations. Again, we could have done all of this through the Azure portal. We could have come in here and configured our VNGs and our LNGs locally along with our private IP addresses, as well as configured them and configured the connection objects. Connection objects. However, by running this through the CLI, it makes it, yes, it's a little bit longer in order to do it, but it makes it much more repeatable and much more secure for the future.